Hey everybody, it's Mr. Recore. I just wanted to try this new technology out. It's going to be a little choppy, so I just appreciate your your understanding. Trying out this new pen writing tablet, and also just trying out this software in general, seeing how this works. So everything I do here will definitely still cover in class, but as we go along further in the year and I do more and more of these, hopefully it'll sort of be a better way to learn. So just want to talk about vector addition in more than one direction. In class, we started talking about it, doing it just back to back or the tip to tail method. So we'll do a quick review of that. When you have two vectors, we'll call each one of these vectors. Hold on, let me just get here. Perfect. Call this one vector A, and sorry for my writing, this one will be vector B. So we're just going to add A plus B together, and as we did in class, we do the tip to tail method. So you bring the first vector, this would be vector A, and move vector B right next to it so that its section that doesn't have the arrow automatically goes right to the tip of the arrow of vector A. So basically you just put them end to end right next to each other, both pointing in the same direction that they were originally going. Where the first one starts, that would be vector A, the second one ends. Or, sorry, where the first one ends, that would be vector A, the second one, vector B, would begin. So what happens is you can really replace this section, because it's essentially two lines going in a straight thing, and just get rid of it. You don't need that arrow anymore because we have a start all the way over here, and we have a clear end all the way here. So this vector, which would be labeled vector A plus B, allows you to just take those two, make a single vector, where vector A was 5 meters to the east, vector B was 5 meters to the east, so A plus B would simply be 10 meters to the east. Sorry for the writing. Alright, so that's the simple way to add vectors tip to tail that are in a straight line. If we had other options which we went over in class, if one was pointing in one direction, one was pointing in the other, so if A was pointing 5 meters to the east and B was pointing 2 meters to the west, for example, you would subtract them. Just kind of do that up here real quick. You would subtract them. There's our A, the tip. You don't really want to just put them right on top of each other because then it's hard to see. But that would be our vector A, 5 meters. Here's our vector B, 2 meters. So our final vector would be from the beginning of the first to the end of the second. Oops. To the end of the second. So this would be our final vector. And because they're in opposite directions, you subtract them. So this one would be 3 meters. But like we've been doing before, the final vector, A plus B, would still be to the east because the 5 meters is bigger. So it wins. The east direction wins. So that's just another quick example. But what happens when we do try to add two vectors like this? Say we were telling Josh to walk 5 meters east and then turn and walk 5 meters north. His distance would be what? Take a second to think about it. His distance, total traveled. I apologize, I think this arrow is getting a little bit cut off up here. But just figure it being right there. We'll redraw it in a second. The total distance, while I was drawing that, should have come up with a total of 10 meters. 5 meters east plus 5 meters north. For distance, the direction doesn't matter. So the total path length would be 10 meters. But that's not what the displacement is. So what we have to do is we use the exact same method, but we have to go a few steps further. So we're going to just do the tip to tail. We're still drawing 5 meters east. That's our first vector. And then starting here, we're going to draw 5 meters north. So this is 5 meters, and this is 5 meters. Okay, so where's our added value? Well, it works exactly the same way. Let's see if I can switch pen color here. Pointer options. We'll go to red. So the final result is same as last. You start on the end of the first one, the first arrow, the first vector that doesn't have the tip pointing from it, and we're going to draw a line with an arrow to the second. So you might see where this is going to lead us. I'll draw a nice line, and where our arrow ends, that's where our arrowhead would be. So this is our value. We'll get to the terminology in class tomorrow. But here's our value. That is our vector A plus B. But you might be thinking to yourself, well, it's definitely not 10 meters. We know that right here, this one's 5 meters, this one's 5 meters. So the shortest distance between any 2 points is a straight line. Well, these are our 2 points. Right here we're circled, and right here where it's circled. So that can't possibly be 10 meters. So what I'm telling you right now is that 5 plus 5 in physics does not equal 10. How cool is that? That's so cool. So we got to figure out what it is. Well, hopefully you can identify that it's going to be less than 10 because we're not going all the way. It's definitely quicker and shorter to go from point here to point here, just in a straight line. So it's going to be something less than 10, but we got to figure out exactly what. And some of you might be looking at this and saying, uh-oh, that's a triangle. So we've got to use good old Pythagorean theorem. Trying to get a little faster with my writing here. Shorthand, THM, for theorem, where it says that side A, quantity squared, plus side B, quantity squared, equals side C, quantity squared. So we've got to figure out, we know A is 5 meters. Oops. We know A is 5 meters, so we got a 5 squared. We know side B, which is the upside, is also 5 meters. So we got a 5 squared there equals, we'll figure out what C squared is. So 5 squared plus 5 squared. Well, what's 5 squared? I think many of us know that to be 25 plus 25, which equals 50. So 50 is our C squared. To figure out what C is, I know many of you can identify. I'm just going to come up here for ease. We know that C is going to be the square root of 50. Well, what's the square root of 50? You can plug that into your calculator, and honestly, I don't have it. Whoa, what's going on? I don't have it in my calculator, but it's going to be something along the lines of 7.1, somewhere around there. 7.1 meters. Make an approximate sign instead. Because 49, square root of 49 is 7, so just a little bit above 7 meters. So what we just figured out is that 5 plus 5 is about 7.1. That's kind of cool. So the next thing we have to do, which we'll do in class today or tomorrow, is we've got to be able to figure out how this vector is identified. I can't just say move 7.1 meters because vectors have direction. So we've got to be able to identify what direction this vector is pointing. You might want to just simply say northeast, but we want to be a little bit more specific than that. Northeast, well, that could be northeast. That could be northeast. That could be northeast. Really, any combination of these could all be northeast. So we got to get a little bit more specific and put an angle to it. And that's something we're going to work on tomorrow. So we're going to figure out a way to determine what this angle is. When we get this angle, we'll be able to truly identify the direction that we're looking for. So, for your homework tonight, all you have to do is copy down this slide. So I recommend just pausing the video. I want you to just draw this slide. I'll check it to make sure. And then what I'd like you to do is to figure out, using the same thing, draw it right here. Sorry. Again, still getting used to this. So figure out using the same thing. We'll have different pen color. Do green. Just very quickly, all you need to get up to is this point right here. Is adding two vectors. The first vector being 3 meters. Wow, that green's not really helpful. 3 meters to the left, to the right. 3 meters to the right plus 2 meters south. So I want you to try to add these for homework as well. And I'll be looking for this. Just showing the work, Pythagorean theorem. Draw the actual resultant, the actual result of these, just like, so the 3 meters would be here, the 5 meters, except it's going down. This thick red arrow, red vector, would be the result that I want you to draw as well. So draw this picture and figure out what the length will be, the displacement, for a 3 meter vector going to the right with a 2 meter vector going down after it. Try to add those as well for the homework. All right, thank you very much, and hopefully this went pretty well. See you tomorrow.